Hi, everyone. Thank you for joining us at the Microsoft Fabric UK user group. I'm your host, Leon Gordon. And as always, we have an amazing session for us to come together as a community and learn together. Unfortunately, those of you that are very wide-eyed around us will know that we don't have my co-host with us today, Pragati Jain. Unfortunately, or fortunately, should I say, she's still enjoying maternity leave following the birth of her child. So I hope you would all join me in congratulating her, but unfortunately, she's unable to join us today. But nevertheless, we do have a fantastic session for you today. We're very happy to welcome back Michael Kovalsky for today's session on optimizing and automating fabric scenarios with Semantic Link Labs. Hi, Michael. Thanks again for joining us.
Hi, Leon. Yeah, great to be here. And thanks for inviting me.
No problem at all. Really excited to dive into today's session. So I'm not going to beat around the bush. It would be great if those joining us in the audience can let us know where in the world you're joining us from. And Michael, I'll hand over to you for your session.
Great. Thank you so much, Leon. And just to make sure, if people have questions, feel free to write them into the chat. And Leon, feel free to interrupt me, and we'll take questions as we go. So my name is Michael Kovalsky, and I work at Microsoft on the Fabric Customer Advisory team, and I primarily advise customers on optimizing their semantic models, DAX, and all that kind of good stuff. More recently, I've gotten involved, since the launch of Fabric, got involved with Semantic Link and seeing the various applications that it can have for the Power BI community. Previously, I'd done a lot of work with scripting regarding Tabular Editor and gone quite far with that, and have taken a lot of those learnings over here to Semantic Link, where we can enable some of those scenarios for automation inside of Fabric. So that leads us to today's session. Just a quick agenda here. So we'll start with an intro to Semantic Link, and then we'll get into Semantic Link Labs, where we'll cover some highlighted features. We'll go through some demos, and so we will absolutely not be going through all the Semantic Link Labs because there's just way too much to cover in 1 hour. So we'll be going over some of the highlighted features, as well as some new features that just came out recently and were launched at FabCon in Europe. So what is Semantic Link? So Semantic Link is a Python library to be run inside of Fabric notebooks. And this library was originally intended to be used for data scientists to help them connect to be the bridge between semantic models and data scientists, noting that data scientists generally know Python, so they can interact with semantic models more easily through Python in a notebook, rather than querying the actual semantic model itself in the semantic model environment, and to do more data science oriented tasks within the notebook and be familiar with Python. As it turns out, Semantic Link is also incredibly useful for Power BI admins and developers, and that's what I'm here to show you today. So what are some of the primary scenarios where Semantic Link is useful for folks in Power BI? First off, you have the set of list functions, which provide easy access to the semantic model metadata. As an example, you have list tables, list measures, list columns, list relationships, and these all show you a list of, say, for example, list table shows you a list of all the tables and their various properties. List columns shows you a list of all the columns within all the tables in the semantic model and their various properties. And this just provides you a really easy way to access this metadata. You don't have to open up the model in Power BI Desktop or any other tool. You just have it right there available to you in Fabric. And if you're looking to do some kind of automated documentation, this is kind of like the perfect thing, because it provides you all this metadata in essentially data frames or tables that you can save down and check how things are changing over time, all that kind of good stuff, like an automated data dictionary. It's now extremely easy to do this kind of thing. Previously, it was definitely much more challenging. You also have the capability of running DAX inside of a Fabric notebook using Semantic Link, as well as running DMVs, XMLA, and TIMSL commands. So this allows you to actually query the data from the model. So you have access to the metadata, to the list functions, as well as the data running DAX and DMVs. So all these things you have pretty powerful programmatic access to inside of a notebook. You do not have to leave Fabric to get this information. So these things here really just lay the foundation for a bunch of automation scenarios. So these are kind of these basic pillars which allow you to do some pretty interesting things. And that leads us to Semantic Link Labs. So Semantic Link Labs is also a Python library, and it's an extension of Semantic Link, including an additional 300 functions, or more than 300 functions. And this library, Semantic Link Labs, is open source on Microsoft's GitHub. So all the code is open source, and you can see it. In fact, it's also a great way to kind of get started and start to learn Python if you don't know it already. It will definitely come in handy, although it's not necessary to get started. And some of the beauty of Semantic Link Labs is that there's auto authentication. You're in the Fabric notebook, you're in the Fabric environment, so it knows who you are, and whatever you query, all the access that you have is taken into account. So, we all know that dreaded pop-up window where you have to, use your authenticator app to put in a number and go through this whole process of authentication or what have you. None of that all that's taken care of for you behind the scenes, and it just streamlines the whole process. So interacting with the artifacts in Fabric is a much more seamless experience than potentially other ways. So and it makes sense because you're in Fabric, so it should know who you are, and thanks to Semantic Link, it does. So what does Semantic Link and Semantic Link Labs give you? It gives you programmatic access to various Fabric artifacts, and the ones that we're going to focus on are semantic models, reports, lakehouses, and warehouses. And there's a lot of attention around semantic models, primarily due to my background in semantic modeling, but we will not forget about the other three mentioned here as well.
Hi, Michael. Sorry to
go ahead.
You said you wanted to take questions throughout. So we have one coming in from Dan, and Dan asks, can SemPy be loaded into a Databricks notebook and used the same way?
Yeah, the answer is no. That's a short answer. This question comes up a lot, and it's more feedback for the Semantic Link team. I appreciate the feedback, but as of present, Semantic Link and Semantic Link Labs are only possible to be executed inside of Fabric.
Excellent. Thanks for taking the question.
Sure. So for those of you familiar with Power BI and Fabric APIs, these are generally used by much more technical people because they require a lot of coding to set up, whether it's a C# application or a PowerShell script, and you have to go through all of this authentication. It's not easy to set up. In fact, before Semantic Link, I never used these APIs, and people may be surprised. They're like, oh, but you're pretty technical, so we would think that you would have used them. And oddly enough, I didn't, because it was just kind of too much of a pain to go through all that work and to do it. And now we've made that much, much simpler. We've significantly reduced the barrier to entry for these Power BI and Fabric APIs by creating wrapper functions for these APIs. So the APIs can allow you to do some very cool things, but previously, because it was so challenging, it was reserved for only a few, like a select group of highly technical people. Now, literally anybody can have access to these things and do some very interesting things without even knowing that they're using an API. Like, for example, when you go on your phone and you open up an app, it's calling all sorts of APIs behind the scenes, but you don't know it. And you're probably glad that you don't know it because it would be overly complicated for most people. And that's kind of what we've done here. We just made these highly technical things much simpler so that really they're accessible to everybody. For those of you familiar with semantic modeling, you're likely familiar with the Tabular Object Model, or TOM. It's the API that makes semantic modeling changes work. So whenever you make a change to a semantic model, whether it be in Power BI Desktop, Fabric in the web, or a third-party tool like Tab Editor, it's using TOM to make those changes. So TOM has been added into Semantic Link Labs, and in fact, there's over 100 functions specifically around that to make programmatic viewing and editing of your semantic model easier. And last thing I want to say on this slide is that you absolutely do not need to be a Python expert to use Semantic Link Labs. In fact, about a year ago, I didn't know a lick of Python. And so when I've been designing this library, I've designed it primarily for people who don't know Python. And I think you'll see that throughout the session. Obviously, if you know Python, you can go much further, but you can absolutely get quite a bit of value not knowing any Python. So what are the goals of Semantic Link Labs? So first off, kind of to reiterate some of the things I've been talking about earlier, is that we want to make things that were previously highly challenging for developers and admins incredibly simple, to reduce these highly technical tasks to just a click of a button. Additionally, the Power BI and Fabric community have quite the insatiable appetite for new features, and the product team is working very hard, but obviously there are limited resources, and this provides us a way to enable certain features that have been requested by the community and put them into the hands of our customers, and also so they can start using them and collect that feedback. So eventually, when these things do make their way into the product, they can be done in a more intelligent way, having collected that feedback and seen how folks are using these tools. And lastly, we just simply want to showcase the power of Fabric notebooks. In my opinion, notebooks are the most powerful aspect of Fabric. They're the glue that holds everything together. When Fabric was first launched, I think people were thinking, oh, the key feature of Fabric is OneLake or the Lakehouse or RTI. Notebooks allow you to control all these things, and the notebooks kind of have its tentacles in everything, and it's extremely powerful. And I think that at first, a lot of folks, especially in Power BI, they were a bit spooked by notebooks, thinking, oh, that's Spark or that's Python. I don't know Python, so I'm not going to use that, and I'll stay away from that. I'll keep in my box of Power BI. But I think now we're starting to open that up, and people are seeing that notebooks can be highly relevant to Power BI folks, and especially to do tasks that previously would take you hours or days or weeks to do them in a click of a button. So before we get into the demos, let's go to GitHub. So actually, Leon, if you could share the link to this GitHub in the chat, it would be appreciated. So here we are on the Semantic Link Labs GitHub repo, and As you can see, like all the code is available here for you to see here. You can click in and see everything. When you come here, some of the first things to do would be to read the documentation, oftentimes overlooked, but very, very important. So we just click here, and here below in red, we see all of the functions in the main package. And then we have additional sub packages with additional functions. And all of these contain, you have all the functions in the library. They're all documented with descriptions and showing all the parameters that are available, as well as what the function returns. So if you want to use a function, before you use it, it's probably wise to come here and read more about it so you can take advantage of all that it has to offer. And there are constantly, we're constantly making new releases of this. So just because you're using a function doesn't mean that later on there won't be additional things added to it, additional capabilities. So it's good to come back here and check and see that that you're taking advantage of all that it has to offer. If you have found a bug or have a question, or if you have an idea for a new feature, you can use these two links here to do that. And another thing to help you when you first get started is, because there's over 300 functions, so it's easy to get overwhelmed maybe at first just by looking at the functions. So here's a kind of a top 15, 20 list of what are the featured scenarios in Semantic Link Labs. These are some of the things that it can help you with. So if you take a look at this and see, this particular thing seems interesting to me, it could help me. So just click on the link and go from there. We also have these helper notebooks to help you get started. So you can just click on the link here. And you have all these notebooks. They're categorized by the subject area. And you can just click on one of them. And you see here, you can download this notebook, put it into your workspace, and it's just an easy way to get started. It has the code for just getting started with various scenarios, and even has embedded videos which show you what things do, where applicable. And to make things even easier, we've actually used Semantic Link Labs to help you learn Semantic Link Labs. So you can copy this little script here, run it in your notebook, and it will automatically load all the helper notebooks into your workspace, or the workspace that you choose. So you don't have to sit there and download each one individually and figure out how to import them into your workspace. You just run this code and you'll have them all. So when you're first getting started, you'll obviously have to install Semantic Link Labs in your notebook. And so this here is the code to do that. And then once you've done that, you'll need to just import the packages. So this code does that. So the helper notebooks is not required. It's just to help you. This section here is required whenever you use Semantic Link Labs. And one other thing I want to show here is the releases. So we have over here, you can see we have this shows all the releases for Semantic Link Labs and essentially all the changes that have been made since its inception. So you can come here and and see all of the different fixes and new functions which have been made available over the course of time. Okay, that being said, let's get into the demos. So for those of you who are developing semantic models, I would hope that you're using Tabular Editor's best practice analyzer, and also the set of best practice rules that we published on Microsoft's Analysis Services GitHub. A few years ago, we published a set of about 65 rules, which can be run in Tabular Editor's best practice analyzer, and these rules are codified by the experts both at Microsoft and in the community regarding Power BI and semantic modeling. And following these rules will help your semantic model be better designed and also help to optimize performance. If you're not using this already, I highly suggest that you do, because if you're not, you're at a serious disadvantage. And all these tools are free. So what we've done here is integrated that into a Fabric notebook. So you don't have to leave Fabric to have that experience. And for those of you who are not able to, your company won't let you use third-party tools, you can take advantage of this, because here we are having that information inside of Fabric. So as you can see, all we have to do is call this function run model BPA. We specify the semantic model name and the workspace, and this will provide us with a visualization of the violations of that particular model. You can see all the violations are categorized into these different categories. You can click on the categories and see the rules which violate those particular categories. If you hover over a particular rule, you can see description, which gives you more context for that rule. And if you click on any of these blue hyperlinks, it'll take you to a website, either by Microsoft or by an MVP, which will give you more context as to why the rule is important and why following it will help make your semantic model better. And as you can see here, you absolutely do not need to know Python to be able to run this. I mean, all you're doing is putting in the name of the model in the workspace and calling the function, right? I mean, this has basically been reduced to, middle school math, plug and chug, right? There's no serious coding here. All that work and heavy lifting is done for you behind the scenes. So one additional thing we've done here is, because we're in a Fabric notebook, and I mentioned that Semantic Link can access not just semantic model metadata, but also running DAX and DMVs, we can actually make these rules even more powerful. If you come here and enter a parameter called extended and set it equal to true, it'll actually obtain Vertipaq statistics about your model, save them as annotations to your model, and run additional rules that give you insight based on not just the model metadata, but also Vertipaq statistics. So, and this is really powerful. So as an example, you can say you have a table in your model, which is an import mode table, and it's 1 billion rows, and it's not partitioned. This can actually tell you, identify that scenario because of the Vertipaq statistics, and tell you it's probably a good idea to partition that table, because trying to process a 1 billion row table in one go is probably going to take quite a bit of time. So this is some of the advantages of being able to work here inside of a notebook with access to not just the semantic models metadata, but also DAX and DMVs. So what other things can we add to this to make it more useful? So I gave a session on Semantic Link Labs several months ago, and someone asked, hey, I like these best practice rules, but could I see these rules in Spanish or in a different language? And we actually had 3 folks from Microsoft and the community translating our previous best practice rules into Spanish, Italian, and Japanese, which was just a ton of work and all manual effort. And I thought, okay, here we are in a notebook. We have access to Python. We have access to all the Python libraries. Certainly, we can use that to translate these automatically. And it turns out that we can. So all I have to do is come up to the parameters and set the language. We can set it to any language we want. We'll go through some examples here, but you can literally put in any language. If you're a Star Wars fan, you can put in Klingon, and it'll translate into Klingon. Not sure how useful that is for your customers, but nonetheless. So here we have it in Swedish, and we can literally put this into any language. It's not just the most common languages, literally any language. And those folks who were translating the rules into the other languages, the 3 languages, and taking tons of their time to do that, they are now free to go and work on things that are much more important and less mundane. And we didn't just get 3 languages, we got all the languages. So can we kick this up another notch? A customer came to me and said, hey, I like this BPA, but I don't just have one semantic model. I have 6,000 semantic models across 12,000 workspaces. If I have to run this manually for all of those, it's going to take me to the end of time to do it. And there has to be a better way, right? And so there is. We have this function, which is kind of an extension of the previous function, and this is called run model BPA bulk, where instead of specifying a semantic model name, you specify either a workspace, a list of workspaces, or workspace equals none. In that case, it'll scan all the workspaces you have access to and all the semantic models inside all those workspaces. In this case, I specified one workspace, so it will scan all the semantic models in this workspace and analyze, get the BPA results, all the violations, and instead of showing us a visual, it will save that information down as a delta table in our lakehouse. So it scanned all the models, and it saved that information to this model BPA results delta table. And every time you run this function, it appends the data. And as you can see, it has this run ID and timestamp. So as it's appending, it gives a new run ID and a new timestamp, the time that you ran this function. So you can actually see how your models are improving over time. So we could have stopped there, but we didn't. What you really want to analyze is you want to figure out, what of these 6,000 semantic models should I focus on first? The one maybe that has the most extreme violations. So this function that we just ran here dynamically generates a direct lake semantic model based on this delta table, which we can then use for our analysis. And this next function dynamically generates a report based on the template that's based on that direct lake semantic model that we can use to do this analysis. So here we come into our workspace and we see that we now have 2 new artifacts. We have model BPA semantic model and model BPA report. And those are generated by those 2 functions. We can open up the report, and here we see a report that gives us insight into all the violations across all the semantic models in that run. So in fact, in the whole history, if you want to. So here we can see we've scanned one workspace, which has 11 models and all sorts of violations. This main page gives us more of a high-level view, and the model view looks into one particular model, so you can see the specific violations for a particular semantic model. And also, we can see what all the rules are. So now this customer can run this and find out across their whole environment which semantic models have the most violations and the most serious violations, that they can prioritize their efforts to improving those first without having to run this manually many times.
Hi, Michael. We just have a couple of questions coming in, if I can interject.
Sure.
So the first question comes in from Fernando Calero, and he mentions that he ran a function, and I'll just go ahead and share the function. The function was list_semantic model object report usage. And what happened for Fernando is he got the error. The report wrapper function requires the report to be in the PBIR format.
Yeah, we will get there. Okay, we will get there in this presentation. You're a bit ahead of schedule. So,
no problem at all. We'll take that one.
We'll answer that in a bit. Yep.
Excellent. And then one more question from Dan, which I believe is probably very current, is the code that you just ran in the notebook. He asks, would this code hit the front-end capacity, and could there be any inherent throttling or controls over how hard it hits the capacity for this bulk information?
Yeah, so that's definitely a good question. Running this will cause the models to go into memory, which is not ideal, but it's kind of seemingly necessary for now. I probably recommend you to start off slowly and don't try to go through all the workspaces at once off the bat, to kind of play with this and see how things go. It also depends on the size of your semantic models, like how many tables and how many measures. The bigger the semantic model as far as the metadata, then the longer each BPA scan takes. So each scan is pretty quick, but if you have a larger model and many large models, then it will take some more time. So there are no current recommendations for this at first, other than just to don't go crazy with this, like be responsible, and just try bit by bit and see what works for you and your company.
Excellent. Thank you.
Sure. Oops. Okay. As I somewhat alluded to earlier, we have access to Vertipaq statistics, so we can actually see the Vertipaq analyzer statistics inside of a Fabric notebook. So we just simply call the Vertipaq analyzer function and specify the semantic model name and the workspace name, and we can see all of this metadata or all this information that's helpful for optimizing a semantic model inside of a Fabric notebook. Obviously, we can still use this access information inside of DAX Studio or Tabular Editor 3. Now we just have another option where we can have it inside of Fabric for you, available to see. So, and the other thing about this is that in other tools where you can access information, it's just static. And here you're saying, well, looks static to me too. It's just this kind of, graphic where you can click and see different data points here about your model. And that's true. But there are additional parameters here that you can call. So you can call the parameter export and set it equals to table. And what it'll do is, instead of showing you the visual, it'll save down that information to a delta table, similar to BPA, and also appending. So you can actually save this information down and potentially even save it down over time, so you can see how your model is growing or shrinking over time as you're making changes to it. Something that previously was was, I guess, possible, but nothing really out of the box. Now you have something out of the box where you can do that. You can save information down and play with it, and filter it as you would like to, just even using SQL or using Python data frames. So it's now actually, you actually interact with information, not just see it statically.
And then, sorry, Michael, just a poignant question that's coming in.
Sure.
It comes in from Dwani. Hopefully, I'm pronouncing your name correctly. How does the Vertipaq analyzer work in case of direct lake mode, as all data will not be in memory?
Yeah, this is a very good question, and I'm glad you asked this question. Because we're inside of Fabric Notebook, we have access to everything. So direct lake models, where does data come from? It comes from a lakehouse or the warehouse. So primarily the lakehouse. So what we can do is, in the case of direct lake, if we want to get something like the column cardinality, we need to actually query the data. And if you do this using other tools, it will actually run a DAX query against all of the columns in your model, putting all the columns of your model into memory, which potentially can cause your capacity to go down. And this actually has happened at a customer. So that's not good. We want to avoid that. So if you do this here, that doesn't happen. What it does is it actually queries the lakehouse directly using Spark. So there's no DAX actually run for direct lake to get this information. It's all queried directly to the lakehouse. So nothing is put into memory inadvertently, or nothing's put into memory, and nothing is done inadvertently to cause your capacity to potentially go down. So you can run this with peace, knowing that it will not put columns into memory inadvertently for direct lake. And that's just another aspect of the beauty of doing things inside of a Fabric notebook, is you can call and access any of the pieces in Fabric. It's all connected, and they're all connected by the notebook. So if this were like a real live session, I would say, who here has tried to translate a semantic model to different languages? And I presume maybe there'll be a few brave souls. And of those brave souls, probably no one would have actually succeeded. If you had succeeded, I would love to hear your story. And I commend you for that. You must be extremely resilient and have a ton of patience, something that probably most people don't have as much of. Definitely don't blame them. And just the reason no one's really done this is because it's just way too difficult. And now it's extremely easy. So all we have to do is call this function translate semantic model, specify the model name, and the language we want to translate into. We can either put the language name or the language code. Here I've used language codes. As you saw in BPA, I use language names. Doesn't matter. Either one works. So IT is Italian, ZH-CN is Chinese. So we run the function, and literally within a few seconds, it's used AI to translate all the names, descriptions, and display folders for all the tables, columns, measures, hierarchies, and levels. Coming to our report, we specified in the URL the language is Italian, and just like that, all the report titles, as well as, let's go into the semantic model, we see the tables, the columns, measures, and hierarchies and levels, and they're all in Italian, just like that. It's literally too easy. Now let's put in the Chinese. We update the language in the URL to ZH-CN, which is Chinese. And just like that, it's all in Chinese. Previously, this was so difficult. Now, there's no reason not to use this. If you work in an organization that has people that speak different languages, there's no reason not to use this and just to make their lives better. I mentioned before that we have these wrapper functions for Power BI and Fabric APIs, and also a few Azure APIs. So previously, if you wanted to export a report as a PDF programmatically, you'd have to call 3 APIs, set up authentication, C#, PowerShell, a ton of work. Now, you just call this function, and all that's taken care of for you behind the scenes. I want to show an example of a more complicated API, because there are ones that are much simpler than this, but this one kind of shows you how simple it gets when actually behind the scenes it's quite complicated. So all you do is call this function, export report, specify the report name, the format you want to download it as, and the file name, and obviously the workspace that the report exists in. We just press play, and this report is saved as a file in the Lakehouse attached to the notebook. There it is. We can now then go into the OneLake File Explorer and sync from OneLake and refresh it, and wait a moment. There our PDF shows up. We can open it, and just like that, we have our PDF. And just like the API allows you to do, if you want to filter your report or just export specific pages or visuals, all that is possible as well, just within this function. So again, something that previously was highly technically challenging to do programmatically, now it's plug and chug. Anyone can use this. You do not have to be a Python expert at all. So now let's get into some new features. And these features are all available as of 0.8.0. Now we're actually already up to 0.8.6. So I mentioned and covered a lot of things that are relevant to the semantic model. And just in general, a lot of love has been given to the semantic model regarding programmability, but the report, not as much. And that's all about to change. So here we have what I call the report wrapper. This is not an API, but it's something close. So to answer the gentleman's question from earlier, this report wrapper and everything around it requires the report to be in the PBIR format. This is a format being pioneered by Rui Romano. Currently, it's in public preview. Eventually, it will go to GA, at which point every report that is opened will will be automatically converted into PBR format, making this more useful. If you're saying, oh, currently my reports are not in PBR format, so I can't use this, obviously that's the case, but I built this for the future, not for the past. So, soon enough, all reports will be in PBR format, and you can actually use PBR format today if you'd like to. It's in public preview. But soon enough, all reports will be in that format, and at which point this will be useful for all used reports. But there's no sense in building something for the past. So if you go into that, here we have a report that's in the PBR format, not the most beautiful report, but one that's certainly well in testing. This is what we use for the demo. So we just call this report wrapper, where we specify the report name and the workspace in which the report exists. We just need to call that once. Once we do that, we have access to all this good metadata. So we can see all the pages of the report and various properties of those pages. We can see all the visuals in the report, as well as tons of properties. In fact, more properties you can show on the screen. You see the ... in the middle. And you can see what are all the report filters and their properties, what are all the page filters and their properties, what are all the visual filters and their properties, what are all the visual objects, in other words, what are all the columns or measures used on each visual in the report, and their properties. You can see, do we have any custom visuals in the report, and are they used in the report? Do we have any report level measures? In this case, this report doesn't have any. Do we have any bookmarks? And has anyone edited any of the interactions that would show up here? So this provides you easy access to all that metadata without having to open up Power BI in the web or Power BI Desktop. You can access it for any report in PBR format instantly. And as I mentioned, you just need to call the report wrapper once, and you can see this instantly see all this metadata instantly. So what I've shown here is retrieving metadata. What if we want to actually do stuff and change a report? So let's take a scenario where your company comes to you and says, we have a new theme that we want to apply to all of our reports. And you may have hundreds of reports or even more. And you're thinking to yourself, oh God, like we better just mark off the next few weeks as like, doing a ton of manual labor, opening up Power BI Desktop, waiting for it to load, loading in the theme file, clicking save, closing it, publishing it, doing the same thing for the next one, for the next one, for the next one, until your eyes are ready to bleed. But we don't have to do that anymore. So watch. I've taken 2 theme files and put them into the lakehouse attached to my notebook. You can also reference theme files from online sources like GitHub or other places. We're just going to call the report wrapper and say set theme and specify the theme file path. In this case, this dark theme from the lakehouse. We run the function. A few seconds later, we open up our report, and it's now in dark mode, just like that. We didn't open up Power BI Desktop, didn't open up Power BI on the web. It's just done. Let's set it back to light. Let's set to light mode. And it's done. In the time it takes to open up Power BI Desktop and do this for one report, you could have cleared out a whole workspace or more of reports automatically in one click. You've seen here, this is for one report, but with Semantic Link, you can loop through all the reports in your workspace and do this for all those, very, very easily. So this just shows for one report, but it's kind of just as easy to do it for one report as it is to do it for many reports. So all that hard work of having to open up Power BI Desktop, make the changes, it's all gone. So I call these action functions because they actually perform actions. And that was one, set theme. There are other ones as well. Not all of them, we won't cover all of them today. You can find them all in the documentation regarding the report wrapper. These are very simple yet powerful functions. And this is just the beginning. So here's a scenario. You have a semantic model, and that semantic model feeds one or several downstream reports. Classic scenario is you go into your model, you change a measure name, and you're just praying that you didn't break any reports. Because if you did, you don't know which report, and you don't know within which report, on which page, within which visual or filter did something break. Now you can know all that information instantly. Let's take a look. As expected, we call the report wrapper, and we call this function list semantic model objects. So this function tells you across all the visuals and filters, what are all the semantic model objects used in that report. So as an example, we can see that we use this class column from the dim product table, and that's used on this visual on the main page, and this is the visual GUID that column, the class column, is used. And you can see that across all these different sources within the report where these objects are used. Now, we also know the semantic model that feeds this report, and we have access to Tom as well. So what we can do is we can call extend equals true, and this will tell us a new column, and that column will tell us whether that object, in this case, the currency name column in the dim currency table, actually exists in the semantic model or not. So as you can see, it's true, and it's true for all of the rows, which means that the report is fine. Nothing is broken. Now, what if you want to see this for all the reports across a given semantic model? So what are all the downstream reports, and what are all the objects used in the semantic model in those reports, and is anything broken? So this tells you that. Same thing as the previous function, just across all the downstream reports. As you can see, it shows true, which means nothing is broken. Good. Let's break something. So we're actually going to connect to the semantic model using Tom from Semantic Link Labs. Specify the semantic model name, the workspace, and we want read-only to be false, so we can actually make changes to the semantic model. So we're just going to change this sales amount measure from sales amount to rename it as sales amount 2. And this will actually change the semantic model. Like these few lines of code, running them, you're making changes to the semantic model without actually opening up the semantic model. And now that we've made that change, if that measure was referenced in any of the reports behind it that use that semantic model, then they will be broken. So let's find out if we broke anything. And here you can see we do have some cases of this being false. And where is it false? It's false when the measure is sales amount. Why? Because that measure no longer exists. It's now sales amount 2. So let's open up the report. And we can see clearly the report is now broken. And what's broken here aligns exactly with what showed in the function in the notebook. So we have a complete mapping of all the reports that use the semantic model, and all the pages and all the visuals and all the objects, and which piece is broken. So to fix it, it's much easier. So let's fix it. We change it back to sales amount. We rerun this function, and if we did everything correctly, we'll see that we're all back to true, which we are. And that means that the report should be fixed. We come back to our report, and we see, yes, indeed, it is fixed, and all the visuals are working properly. So we don't have to play the game of opening up, a ton of reports and looking through all the pages and finding which ones are broken. You can run this function, and within a few seconds, you can know everything and know where to begin. Now, I showed you a BPA, or best price analyzer, for the model, and why should the report be left behind. We have one for the report as well, and by default, it runs a set of rules that actually created for a previous tool called Report Analyzer. They're now run here by default, as well as the rule looking at broken visuals that we showed in the previous demo. So you have a set of rules that you can start with. You can also create your own rules or modify my rules. If you click on these links of the violations, it will take you not just to the report, but to the specific page that has that violation, so you can get there faster. And we can actually make changes to the model or the report here within this notebook, and fix things without having to even leave the notebook or open up Power BI. So with the same problem here that we had in the previous demo, where we have semantic model 2 instead of semantic model, or sales amount 2 instead of sales amount. So let's change that back, and we'll actually see that all these 8 errors go away. We also have at the top of the violations these 2 violations called say avoid setting show items with no data on columns. This property should, in my opinion, never be used. So we actually have a function to take care of this. So you can call this function disable show items with no data. It'll make sure that that property is not set for any of the visuals in your report. And just like that, it's done. Let's rerun the report BPA. And we've improved our report so that it follows these 2 specific rules without having left the notebook. And there are additional action functions as well to solve more of these violations as well. So we can actually not just identify the issues, but actually solve these issues within the notebook as well. When it comes to optimizing a semantic model, most people start with looking at what is the measure in the semantic model that has the worst performance. And while on the surface, this seems like a good idea, in practice, it's kind of half right. So would it be better to optimize not just the worst performing measure, but the worst performing measure that's also used the most? Because if you're going to optimize a measure that's never actually used, you're not really helping anybody. So how do we find out what's the most frequently used measure or column in a report? And the answer is, we call this function. This function lists semantic model object report usage, looks at a semantic model, finds out all the reports that semantic model feeds, looks at all the semantic model objects across all the pages and all the visuals and all those reports, gets a unique list, finds out all the dependencies in all those objects. Say, for example, you have a measure that references another measure, and other columns. It takes all those into consideration and gets that unique list and finds out how many times it just takes account of all those occurrences. So now we know that the most frequently used column across all the reports which feed from this semantic model is the color column in the dim product table. It's referenced 21 times. And we also have a side of this Vertipaq statistics, so we can know if we have a very large column that's used very frequently. And we also know that we have a tie for first place between order quantity and sales amount as the most commonly used measure across the reports. So now crossing this with performance data, we know exactly where to start to get the most bang for a buck. And that concludes the demos for this presentation. So happy to take some questions.
Excellent. Thank you very much, Michael. Another fantastic demo and walkthrough of some extraordinary capabilities that you're building there. So we do have a couple of questions. I know we're nearly at time, so I'll pick a couple that I think resonate well. So this question comes in from Jiwan Kim. And when you were showing the PDF report export functionality, can you change the language by using a parameter at all?
Can you filter the report to a particular country?
Yes.
So the filters for the export report function are based on the report. So or based on the model, really. If you have a model, semantic model behind the report has a country column that you want to filter to UK, so you want to filter the data to the UK, you can absolutely do that. And you can put in any filter for the report that you would like to, based on columns in the semantic model.
Excellent, thank you. And let's just go ahead and go to one final question. Let's take this question from Dwani, and they ask, are there any specific permissions required to be able to run this library within Fabric?
There's no specific permissions to be able to run this library. As far as running these functions against different semantic models or reports, that all depends on your access to those semantic models and reports. It depends what you're running. So some things that you're running may be just viewing metadata, some may be viewing data, some is around reports, just metadata. So all those things require different accesses. So it really all depends on your particular access to those data artifacts.
Excellent.
But anyone can use the library. Yeah.
Perfect. Thank you very much, Michael. So I know that we're at time. There are still some questions. So what I would recommend to those of you that have any questions directly for Michael, please feel free to reach out. We have shared his social media and GitHub contact details. So please do feel free to reach out.
Yeah, and just lastly, I would recommend people have questions, anything you can post on this discussions here. If you have questions or also raise an issue on GitHub. It's a great place for not just to ask me, but to ask the community as well, so we can all participate in helping each other.
Excellent. Fantastic. And the link also to the GitHub is in the comments, both on LinkedIn and YouTube. So Michael, let me thank you once again. Absolutely extraordinary session. So really appreciate you going through that for us today, and all of the hard work that you're doing to transform not only Power BI and reports, but also now Fabric as well.
Yeah, thank you so much, Leon. Great to be on your show.
Excellent. Thank you very much. And I'd just like to thank everybody once again for being with us here again today at the Microsoft Fabric UK user group. You could have been anywhere in the world, but you've been here with us. Stay safe.